In computer networking, the contention ratio is the ratio of the potential maximum demand to the actual bandwidth. The higher the contention ratio, the greater the number of users that may be trying to use the actual bandwidth at any one time and, therefore, the lower the effective bandwidth offered, especially at peak times. A contended service is a service which offers the users of the network a minimum statistically guaranteed contention ratio, while typically offering peaks of usage of up to the maximum bandwidth supplied to the user. Contended services are usually much cheaper to provide than uncontended services, although they only reduce the backbone traffic costs for the users, and do not reduce the costs of providing and maintaining equipment for connecting to the network. Specific examples by country: in the UK, an RADSL connection used to be marketed with a contention ratio between 20:1 and 50:1 within the BT network, meaning that 20 to 50 subscribers, each assigned or sold a bandwidth of up to 8 Mbps for instance, may be sharing 8 Mbps of uplink bandwidth. With the advent of ADSL2+, FTTC offering 40 Mbps services and even FTTP offering 100 Mbps, BT no longer work on contention ratio as a planning rule. In the US and on satellite internet connections, the contention ratio is often higher, and other formulas are used, such as counting only those users who are actually online at a particular time. It is also less often divulged by ISPs elsewhere than it is in the UK. The connection speed for each user will therefore differ depending on the number of computers using the upperlink connection at the same time because the upperlink will only handle the speed that has been implemented on that line. Issues: one of the issues with a stated contention ratio is that it is not, on its own, adequate for comparing services. There is a huge difference between 1,000 users each on a 2 Mbps service sharing a 40 Mbps pipe, and 50 users each on a 2 Mbps service sharing a 2 Mbps pipe. In the latter case, 2 users trying to download at the same time means each get 50% of the speed. When there are 1,000 users, it would take 20 users maxing out their 2 Mbps link at the same time to show any congestion. However, both of these would be quoted as 51 contention. Contention ratios are essentially just planning rules which are used to design a network offering an internet service. The perception of the quality of that service will depend on the actual usage of the users of the service. This is partly why rules such as 21 for business and 51 for residential users came about. The actual usage demands of users have changed over the years, and for evening weekend traffic residential users can be demanding a lot of bandwidth, making 51 contention ratios inappropriate. Contention ratios also only really make sense if dealing with relatively consistent speeds. The fact that a single backhaul in the UK could have users at 500 kbits and users at 100 Mbps makes normal contention ratio planning a thing of the past. In practice, a well-run network aims to avoid links hitting limits, and upgrades the links when they do. This only works where the pricing model allows extra revenue to pay for the high usage links, and this is hitting some unlimited use tariffing models. See also, quality of service. Notes: a good account of the state of the issue in the UK is found in a 2004 OFCOM report on wireless internet. References